in case of priority queue, the jobs will come in normal order, insertion will in normal order, but at the time of deletion, we have to take care the priority value, and according to the priority value, we have to delete them. So it means this is a normal order of insertion. See, first this one came, then this one, then this one, then this one. But when we are deleting, we have to maintain, suppose we are following this one, lower priority means higher priority value. It means the job that will be deleted first is this one. This one will be deleted first, then this one, then this one. Oh, sorry, then this one, then this one. Now see, when same priority, when there is a same priority jobs, then we have to maintain first come first serve. Among these two, which one came first, that will be deleted first. Okay, so how we can implement this, that is the question. Normal insertion but deletion in a different way. So there are two different representation, or you can think about two different solution. One is this one, this type, insertion sort type. Another one is selection sort type. Okay, see here you have to actually ultimately you have to sort them. You have to sort them on the basis of what? On the basis of their priority. Either you can go for insertion sort. It means when we are creating the queue, we will sort them according to their priority value, or we can go for selection sort. It means we have already some jobs in our queue, and then we will perform the selection sort, or selecting the maximum or minimum, whatever, based on this criteria, and then we will perform the deletion. So these are the two different representation for this priority queue. Okay, so if we go for insertion sort, then first came A5, clear, then came B1. So what we will do, we will put B1 into this position. Then came C13. Then what we will do, we will put it like this. So insertion, we are inserting them according to their you can say their priority value, and then finally the D5. So this is the insertion sort way of priority queue representation. Another is we have already this queue where the jobs are inserted in normal manner. Now what I will do, I will search for the minimum value for priority. So this is the minimum value priority. So this two will be interchange. If suppose we are considering this is the front end, if this is my front end, then we know that deletion will be performed from the front end. So what we will do, we will interchange these two operations. This job with priority value 1 and this is the priority value 5, this two will be interchanged. So before deletion, we will perform this selection operation, selecting the minimum job and then putting it in the front position. So to put it in the front position, what we will do, we will interchange with the element that is already in the front position. So this is another way of representation. One is insertion sort way of representation. See, what is the advantage of this manner, this insertion sort technique? The advantage of insertion sort technique is you don't need to take care, you don't have to uh, take care the element what is in the front position. You don't need to take care. It is always deleted from the front element, front position, and then front will be increased. But in the case of selection sort, since we are selecting the minimum one, then interchanging it with the front position, it means in this technique, the normal insertion is when we are inserting, at that time no need of any operation, only the rear will be increased. But when we are going to delete, In this case, when we are going to delete, we have to select using a for loop, and then we have to interchange, and then we have to delete from the front end. It means in case of selection sort, since we are always interchanging and putting it in the front position, so it means no need for separate front element or front pointer is not required. So you can either go for this insertion sort representation, or you can go for this selection sort representation. So it depends on you. So this is our today's assignment, that what you have to do, you have to implement one priority queue, and you will maintain this thing, that lower priority value means higher priority, and it means this lower priority value jobs will be deleted first. Okay, so either you can represent them using this insertion sort, or you can represent them using this selection sort. It depends on you. You can write the both the cases you can write, and you can ask the user which one you want to perform the priority queue operation, in insertion sort way or selection sort way. Based on that, you will call that particular function, and you will show the output in that manner. Okay, so you can either write only one function, or you can write both the function and give the choice to the user. So it depends on you. So this is our today's assignment. You have to represent the priority queue. So it means when you are going to represent priority queue, you have to declare a structure. You have to declare a structure, because here you have already seen, for a particular data some priority value will be added with that data. So that's why we are defining a structure. So structure for priority queue, PQ. So the first thing, it can be any integer value or any character value, it depends on you. So this is the data. Okay, and along with this there will be some priority value PR. Okay. So uh, these two are the members that will be in a structure. Then you can define, suppose you are going to represent it in a way of array, then this is your structure, struct PQ, and this is our queue, those are 5 elements. So this is our array of queues, array of structures, you can say, or with array of structures with two members. What are those members? One is the data itself, another is the priority. On the basis of priority, you have to perform this either insertion or selection sort, whatever. So this is our today's assignment. Now along with this, I will discuss little bit about another type of queue, which is again very useful, and uh, uh, which is very interesting. Now see, what is the use of stack? The use of stack is to perform operation which will maintain a thing like this, last in first out, or first in last out type of sequence. So stack is used for this type of operations, and queue is used for this type of operation where we require first in first out. Normally this first in first out queue data structure is used in our CPU or in our operating system, you can say. So now there is so to implement stack or to implement queue, we have to define two different arrays, correct? If we want to implement stack, we will take one type of array with name S, and if we want to implement queue, then we will take another array to represent queue. Now to maintain two different uh, arrays for two different operations, it sometimes not that much useful. To solve this type of problem, there is one interesting queue operation, or one interesting type of queue is used, which is called doubly ended queue, doubly ended queue, or sometimes called DQ. Okay, doubly ended queue or DQ. So doubly ended queue or DQ is actually a single, you can say a single structure array which can be used for both stack and queue operation. It means we don't require two different arrays to represent stack and queue separately. We have only a single array, suppose A. This single array can be used sometimes as a queue and sometimes as a stack. That is the use of this doubly ended queue. Now try to understand what is the meaning of this doubly ended queue. So normally if this is a queue, the normal procedure of queue is we can insert from one particular end and we can delete from a particular end. We can insert from the rear end, we can delete from the front end. But the meaning of doubly ended queue is we can both insert, and delete from the rear end. Okay, we can both insert and delete from the front end. This is the meaning of doubly ended queue. Now this doubly ended queue having again two types. This doubly ended queue having two types. One is called
Hello.
input. হ্যাঁ বলো। হ্যাঁ কিছু বলছো?
No sir, আমার মাইকটা ভুল করে অফ হয়ে গেছে।
আচ্ছা
এই অন হয়ে গেছে।
আচ্ছা, so this doubly ended queue again having two different types. One is called input restricted DQ. Okay, it means there is some restriction in the case of input, and there is another type which is called output restricted DQ. Clear? Now in case of input restricted DQ, there is some restriction in the case of input. It means only insertion from rear but deletion and deletion from both rear and front. This is the meaning of input restricted DQ. And obviously what is the meaning of output restricted DQ? The meaning of output restricted DQ is only output from front end but deletion, sorry, only output means deletion, but insertion from both rear and front. This is the meaning of output restricted DQ. Input restricted DQ. So the picture of input restricted DQ will be like this. It will be like this. Suppose this is the picture of a queue. Input restricted means only input or insertion from the rear end, but deletion, suppose green color is deletion from both rear and front end. This is input restricted. Now see, if you consider insertion from rear, deletion from rear, what is the meaning of this? It means you are inserting and deleting from the same end, then it will be act like a stack. It will be act like a stack. But if you perform insertion from this end and deletion from this end, this two combination will give you first in first out, it means queue operation. This two combination, insertion from rear and deletion from rear, will give you the operation of stack, and the combination insertion from rear and deletion from front will give you the queue operation. Similarly, if it is some output restricted, the meaning is like this: you can insert from the rear, okay, you can delete from the front, you can also insert from the front, you can also insert from the front, okay. So only in case of output restriction you can, so this one is, sorry, this one is input restricted, this one is output restricted means there is restriction in the output. You can only delete, output means deletion, you can only perform the deletion from the front end, but you can insert, from both rear and front. Now suppose you are using this two combination, insertion from the front, deletion from the front, it means you are only using one of the end, it will act like a stack. But if you perform this operation, insertion from front, insertion from rear and deletion from front, if you use this two combination, it will be act like a queue, okay. So it means one particular array or one particular memory is used in both the cases, or to represent both the data structure, stack and queue. Just restricting the input and restricting the output, you can easily perform both operation of stack and queue in a single memory location. So this is the actual implementation or actual use of our uh, sorry this is the actual use of this data structure, doubly ended queue. This is the use of doubly ended queue, okay. So now okay, so this is কোথায় গেল, আমার মাউসটা না খারাপ হয়ে গেছে, অসুবিধা হচ্ছে কাজ করতে, পাচ্ছি না বুঝি, কোথায় গেল রে ভাই। Okay, so এই যে কি সবচেয়ে সিলেক্ট হয়ে যাচ্ছে, গন্ডগোল হচ্ছে কি করব। Okay, but so this is all about today's class, doubly ended queue and priority queue. The operations of doubly ended queue I will show you in the next class, how we can use both of the end to perform the insertion and deletion. It means in normal insertion, suppose this is your queue, okay, only you can insert 4 elements. So if it is written insert, then it is normal insertion. It means you can perform the insertion from the rear end. Suppose A will be inserted, so your picture will be like this, A, and rear is pointing here, front is also pointing here, okay. So this is the initial picture. Now if it is told that insert from front, So it means you have to insert from this end, you have to insert from this end. Then how you can insert a new element? See, since front is already is at the end, so you cannot insert. So this is a overflow condition for insertion from the front end. Is it clear? That suppose this is your queue, you are going to insert some element in this queue. Suppose insert A. The instruction is insert A. Then you have to understand that normal insertion will be performed from the rear end. It means you have to modify the rear R++ and a new element is inserted. Clear? Now if it is asked to insert from the front, then there must be vacant places in this position. Since there is no vacant position, no blank spaces in this position, so you cannot insert from this front end. Okay, now suppose I have inserted another element B, then the picture will be like this. This normal insertion, and rear will be in this point. Now I have deleted one element. Now I have performed a deletion operation. Then what happened? A will be deleted and front will move into this position. Now in this particular time, if I want to insert a new element from the front end, insert from the front, suppose instruction is given insert from the front C. Now see, I can insert C because there is one free space, and in that case what will happen? Front will move from there to there. Now front will be decreased. So these are the things that you have to take care in case of doubly ended queue. So this is insertion from both end, rear end and front end. Similarly, if I want to delete, it will be normally deleted from the front end. But if I want to say delete from rear, then B will be deleted and rear will be modified and decreased. So whenever there is a deletion, rear or front, you have to check if normal insertion operation rear is increased, then deletion from the rear means rear minus minus. If normal operation of front deletion is F++, then if we insert from the front end, then you have to perform F minus minus. But you have to take care that where is there vacant space available for insertion from the front end or not. It means you have to check the overflow condition for this front insertion separately. Similarly, you have to take care the deletion underflow condition for rear. We know how to check the overflow condition in case of rear and how to check the underflow condition is in front. But in this doubly ended queue, we have to write two different overflow and underflow condition, one for front end overflow condition and rear end underflow condition. Why? Because in doubly ended queue we can insert and delete from both end. So in using this type of things, this type of modification, you can able to write the doubly ended queue operations. It means in case of doubly ended queue, you have two different insertion operation and two different deletion operation. One is normal insertion and normal deletion, or other two is front end insertion and rear end deletion. Okay, according to that these two different operation, you have to modify the overflow and underflow condition. But for today, just perform the priority key operation using array. I have already shown how to implement the structure. Then you have to perform either insertion sort, where we are at the time of insertion we are making them sorted so that we can easily delete according to their priority, or you can use the selection sort operation where we are inserting the elements normally first come first basis, but when we are performing the deletion we are checking the priority, and based on that priority we are moving the data into front position, and then we are performing the deletion. Okay, you can write your code either using insertion or using selection, or if you want you can make your program like this. Both the options are there. According to the choice of the user, one of the option will be executed. So it depends on you. You can do either, you can write both the codes and give a choice to the user, or you can write either selection or insertion. Okay, so with this I'm ending today's class.